Let us now write our standard equation of the parabola with the given directrix at x equal to -9 and the vertex which is at 1, 2. So first off, we are going to locate that one in our Cartesian plane, those mentioned parts of the parabola, just like your directrix, which is x equal to -9. So since that is x, you are going to locate that one on the x-axis and find our -9. So this is our -9 here. So all we have to do is to draw a line which passes through our x, which is equal to -9. And that will be our directrix. So after that one, we are going to plot our vertex. The vertex there is 1, 2. So we have our 1 here on the x-axis, and then we've got 2 here on the y. So this is our vertex. So please take note that on our properties of the parabola, there, one of the properties of the parabola mentioned there that the distance between the directrix and the vertex is equivalent to A. So our A now will be equivalent to, if you count from the directrix to the vertex or vice versa. So from the directrix here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that one is our A. So that is the distance from the directrix to our vertex. Now, since we have those information, we have the vertex, we have the distance from the directrix to the vertex or our A, all we have to do is to write down our equation of the parabola, the standard equation of the parabola. So first off, we are going to identify the opening. So if you try to look at your vertex, the vertex there is on the right side as compared to the directrix. So basically that will be opening to our right side, because you cannot open to the left because the directrix is there. It's gonna be always following where our vertex is at. So that should be our location for our, the turning point of our parabola there. There should be the location of that directrix in there. So that is why we have that one as opening to the right. Now again, we need the information such as our h, our k, and our a. Our h there, based on the vertex here given, this is our h, this is our k. H is equal to 1, k is equal to 2. Our a there, based on the graph, we've counted the distance from the directrix to the vertex, which is 10. So writing down our standard equation, all we have to do is to look at or identify as to what will be the standard equation format for parabolas that are opening to the right. So this is how our equation would look like. This should be y minus k squared, because that is to the right. That will be equal to, and on the right side, we've got positive values in there, so that should be positive for a times x minus h. And then after that one, we are going to plug in those information that we've written at the top. So we have y minus our k there is 2, then squared, that will be equal to 4 times our a is 10 times x minus our h, which is 1. Simplifying this part here, so this should be now y minus 2 squared. That will be equal to 40 times x minus 1. And that is our standard equation of our parabola. Let us now write our standard equation of the parabola with the given directrix, which is y equal to 5. And then our vertex is at 3, 3. So again, we are going to locate our directrix on the Cartesian plane. So since it says here y is equal to 5, so this is where our 5 is. So we will be drawing a line, a broken line passing through y, which is equal to 5. And then after that one, we are going to locate our vertex. The vertex there is 3, 3. So we have 3 here on the x-axis and 3 on the y. So this is where our vertex is. Now, looking at the directrix and the position of the vertex, the directrix there is at the top of our vertex, and the vertex there is at the bottom part. So our opening of the parabola in here will be down. After that one, we are going to identify our h, our k, and a. So our h here is, this is our vertex, so our h is this one, and our k is that one. So we have h equal to 3 and k equal to 3. So next, we are going to identify our a. Our a is said to be the distance from the directrix to the vertex. So the directrix in here, we have that one here, and then the vertex is in here. So if we count the number of units from the directrix to the vertex, this is gonna be from here, 1, and then 2. So there are 2 units away from the directrix and also the vertex. So our a there is equivalent to 2. So writing now our standard equation of the parabola, so we have this one as x, because that is downward, so x minus h squared, that will be equal to negative, because that is downward again, negative 4a times y minus k. And then let us now plot our, or plug in our values here. So we've got our x and then minus our h, that is 3 squared, equal to negative 4, our a, which is 2, times y minus our k, which is 3. Simplifying this part here, so we have our x minus 3 squared, that will be equal to negative 4 times 2, that's negative 8, times y minus 3. So this is our standard equation of our parabola. Let us now write the standard equation of the parabola with the given directrix at y equal to 2 and our focus at negative 5, 10. So we will be plotting those parts here mentioned. So we have y equal to 2. Looking at the y-axis here, we are going to locate the 2. So 2 is here. So we will be drawing a broken line passing through that y equal to 2 as our directrix. Next, we are going to locate our focus. So we have negative 5, 10. On the x here, we have the negative 5 here, and on y, we've got the 10. So getting the intersection of the 2, that will be our focus. Now, again, similar with the vertex a while ago, where is the direction of the vertex? That will be the opening, or the direction of the opening of the parabola as well, with respect to the directrix. So since our focus is located at the top of the directrix, we are going to consider that the opening there is upward. So again, opening of this parabola is up. And then we are going to look for h, k, and a. So we don't have our vertex, so we cannot directly tell our h and k, and so with our a. So we are going to locate our h, k, and so with an a there by utilizing what we had in our graph. So your directrix and the focus, the distance between the two there is 2a. 2a because the distance of your vertex to the directrix is a. From the vertex to the focus is also a. So once you add it up, getting the distance from the focus and so with the directrix, that will be equivalent to 2a. So from here, we are going to count how many units are they from each other. So from the directrix here, we are going to count until we get to the focus. We have 1, 2, 3, 4, 5, 6, 7, and then 8. So our 2a there is equal to 8. Then we are going to look for a because we need information on a here. We are going to divide that 1 by 2, and so with this one, canceling 2 here, our a is equal to 4. So we've got now our a, which is 4, and then we have to find our vertex so that we can have our h and k. Now, since we've got a, which is equal to 4, we can either count from the directrix here 4 units to identify our vertex, or we can also have the focus 4 units to identify the vertex. So I'll start with the directrix here. So we have 1, 2, 3, and then 4. So this is where our vertex is located. And then if you try to count from the focus as well, this is 1, 2, 3, and 4. So there are 4 units from focus to vertex and directrix to vertex. So our coordinate here for the vertex, we've got that one on the x, which is negative 5, and then on the y, which is 6. So this is now our h and our k on the vertex. So we are to write that one here. So our h is equal to negative 5. Our k is equal to 6. So once we have completed all the information that we need, we can now write our standard equation of the parabola. Since this is going up, that means we have x minus h squared equal to 4a times y minus k. So plugging in, we've got our x minus our h, which is negative 5. And then we have squared equal to 4. Our a is 4. And then we have times y minus our k is 6. So simplifying that one, this is now x plus 5 squared equal to 16 times y minus 6. This is now our standard equation of the parabola. Let us now write the standard equation of the parabola with the given information of the directrix, which is x equal to negative 2, and our focus, which is 2, 0. So again, we are going to plot that one here on our Cartesian plane, all the parts mentioned. So we have directrix at x equal to negative 2. So our x-axis is here. This is our negative 2. So basically, our directrix there is a line passing through our x-axis at equal to negative 2. Next, we are to locate focus at 2, 0. So since you've got there a 2 on the x coordinate, so we have to locate x-axis, the number 2, and then we don't have, or we have the 0 there on our y, so we do not move up or down, so we stay on the x-axis. This is our focus. Now again, in identifying our opening, we are going to look at the focus and know what is the relationship or what is the position of the focus with respect to the directrix. So since our focus is to the right of the directrix, so basically opening here will be to the right as well. And then we have our h, our k, and a. So our h here, we don't know the h, we don't know the k, we don't know the a. So that is why on the graph going back, we are going to look for the vertex, and we are also going to look for our a. So take note, our distance from the directrix and the focus is always 2a. So meaning to say we are going to count the number of units away from the focus and the directrix. So we have here directrix. Once I'm counting that one towards the focus, this is 1, this is 2, this is 3, this is 4. So there are 4 units away from each other. So finding a, we are to divide this by 2, and so with that 1, our a there is equal to 2. So we have now our a, so we are going to locate our vertex. So from the directrix, or basically it's going to be more convenient that we start from the focus, because our directrix is aligned in there. So basically, you've got many points on that one. So we start with the focus, counting from the focus 2 units until we get to the vertex. So we have here 1, 2. So this is where our vertex is. And the coordinate of that one is at 0, 0, or the origin. So we have now those information. So we are now ready to write our standard equation. So our h is 0, our k is 0, our a is 2. So writing our standard equation of the parabola, we have that one to the right, so that should be now y minus k squared. That's equal to 4a times x minus h. So plugging in, we've got y minus our k, which is 0 squared. That will be equal to 4 times our a, which is 2, and then times x minus our h, which is 0. So simplifying this one, this is y minus 0, that's y. And then we square that one, that's equal to 4 times 2, that's 8. X minus 0, that is an x. So this is now our standard equation of the parabola. So let us go through with this one with the given information on the endpoints of the latus rectum at negative 2, 3, and 5, 3 with a greater than 0. So again, we are going to plot that one. We are going to locate the latus rectum endpoints in here on the Cartesian plane. So we have negative 2, 3. So this is where our other endpoint is. And on 5, 3, that is the other endpoint. So if you try to look at that one, the orientation of the endpoints of the latus rectum is horizontal. So most likely, when you say horizontal, that should be going up. The parabola is going to be going up or down. Now, since it is mentioned in here that a should be greater than 0, so we are expecting that our parabola will be opening upward. So Starting off, we are going to look for, since we know already our opening, according to our theory a while ago, our opening is upward or up. And then we are going to look for H and K and A. So our H and K, we are going to look for the vertex. But before that one, let us find first our A, because this will be needed in finding or locating our vertex. So since these are endpoints of the latus rectum, the endpoints of the latus rectum has distance from each other, which is equivalent to 4a, or simply the length of the latus rectum. So we have 4a, and then getting the 4a value there, we are just going to count how many units are they from each other. So starting off from here, we have 1, 2, 3, 4, 5, 5, 6, and 7. So they are 7 units away from each other. Since we are looking for A, we are going to divide this by 4. And so with this one, our A here is 7 over 4, or this is simply equal to 1.75. So we have now our A, which is 1.75, or this is 7 over 4. So we are now going to locate our vertex because we need the information for our H and K. But then, since we are given with the endpoints of the latus rectum, we cannot find directly our vertex. Instead, we are going to look for our focus first. Now, the distance between the focus and so with one endpoint of the latus rectum is equivalent to 2a. So if we've got an a here, which is 7/4, once we multiply that one with 2, that will be equal to 14 over 4, or that is equivalent to 7 over 2. We can do cancellation here and on the 4 here. So that will be now basically equal to 7 halves. Or this is 3.5. So our 2a is 3.5. So from there, we are going to count 3.5 from 1 and point to the focus. So from here, we can have 1, 2, 3, and then 0.5. So this is where our focus is. That is with the coordinate, which is 1.5, and then on y we've got a 3. So after locating our focus, we are going to identify our vertex. So vertex and focus, we have an A unit from each other. So we have to move down because this is opening upward. We need to move down a unit. So our A there is 1.75. So from here, this is 1 unit from the focus. 0.75, that is somewhere here. So this is where our vertex is. So our vertex here is with a coordinate which is 1.5, and then we've got the y value because this is close to 1, and then we've taken the 0.75 up. So basically this is equivalent to 1.25. So that is now our vertex. So since we have now the vertex, we can now identify our h. Our h there is 1.5. And then our k there is equivalent to 1.25. So after that one, we are going to write our equation. So we have that one as up. So that should be x minus h squared equal to 4a times y minus k. Plugging in, we have our x minus our h, which is 1.5 squared. That will be equal to 4 times our a, which is 1.75 or 7/4, and then times y minus our k there is 1.25. So simplifying, this is now x minus 1.5 squared equal to 7 times y minus 1.25. So that is now our standard equation of our parabola. So let us go through with this one here. We have the given vertex 2, 1 with vertical axis passing through our 5, 6. So once we say vertical axis, this would simply mean that our axis of symmetry is vertical. So if we are going to plot that one here on our Cartesian plane, we are to locate first our vertex. So we have 2 on x and 1 on y. So we have this one as our vertex, and it says there with vertical axis. So we will be drawing a vertical line passing through our vertex. So that is what we meant with vertical axis. And passing through 5, 6. So locating 5, 6, this is 5 here on x and 6 here on our y. So this is our point 5, 6. When it says there and passing through 5, 6, that would mean that one point on our parabola is 5, 6. So this is how our parabola would look like. So sorry on that one. Okay, let me just... Okay, so that is most likely our half of our parabola because we've got there the vertical axis which cuts our parabola into two identical parts. So given that information, we would now start naming our opening. The opening there is upward. If you try to look at the drawing in there, we've got opening upward there, but you only get to see half of the parabola there. And then we have our h, which is 2. And then we've got our k, which is 1. But for a, we don't have an a, so we have to look for that one utilizing our standard equation of the parabola. Since this is upward, this is now x minus h squared equal to 4a times y minus k. So plugging in, we've got our x minus our h, which is 2, squared equal to 4 times a, which is unknown. And then we have times y minus k. K is 1. So simplifying that one and plugging in the values of our point for the x here, which is 5, our y, which is 6. So we've got here x. From x there, we will be replacing that one with 5. So we have 5 minus 2 squared equal to 4a times y, which is 6 minus 1. So simplifying that one, 5 minus 2, that's 3 squared. And then that will be equal to 4a. 6 minus 1, that's 5. So simplifying this as 9 equal to 4 times 5, that's 20. And then a, we divide that one with 20. And so with that one, our a here is equal to 9 over 20. So from there, we've got now our a, which is 9 over 20. We can now write our standard equation of the parabola with x minus h squared. That will be equal to 4a times y minus k. So replacing h, k, and a here, we have x minus our h, which is 2, and then squared, equal to 4 times 9 over 20 times y minus our k, which is 1. Simplifying this part here, we've got x minus 2 squared. That will be equal to 4 times 9, that is 36, over 20. That will be equal to 9/5. Or you can cancel this one here and that one. Canceling the 4, this is 1 here, this is 5 here. 1 times 9, that's 9. And then 1 times 5, that's 5. And then times y minus 1. So this is now our standard equation of our parabola. So lastly, we have here, right, the standard equation of the parabola given vertex at 2, 4 and passing through 0, 0 and 4, 0. So we are going to draw that one in the Cartesian plane. We've got vertex at 2, 4. So we've got 2 here and 4 here. So this is where our vertex is. And then it says there, and passing through 0, 0. So this is where 0, 0 is, or the origin. And then we have 4, 0 as well. So we have 4 on the x-axis and 0 on y. So this is where now our points. But it doesn't mean that these 2 points are the endpoints of the latus rectum. It doesn't mention like that. So we are going to take that one, that those 2 points are just part of the parabola. So your parabola will be opening downward because we are to connect that one with those 2 points because our parabola passes through that one. So we have our opening, which is downward or down. And then we have our h, which is 2, our k, which is 4, our a, which is unknown. So starting off with our standard equation, so we have our x minus h squared because that is downward equal to negative 4a times y minus k. So plugging in any of this two here. So if you wanted to choose 0, 0, that's good. If you want to replace that on x and y, that's really good. Or if you wanted to have 4, 0 on x and y, then that is really okay. They will be coming up with the same value of a. But for me, I'll choose on 0, 0. So here we've got x, which is 0, minus our h, which is 2, squared equal to negative 4. Our a, which is unknown, times y, which is 0, minus our k, which is 4. So simplifying, that will be now negative 2 squared equal to negative 4a. 0 minus 4, that's negative 4. And then simplifying, this is 4 equal to negative 4 times negative 4, that's 16. And then we've got an a. Divide this by 16, and so with the other side. So our a here is equal to 4 over 16. Or that is simply 1/4. So that is our a. We've got 1/4 on our a. So writing now our standard equation. So we have the x minus h squared equal to negative 4a times y minus k. So replacing our h, k, and a. So we have x minus 2 squared equal to negative 4 times 1/4 times y minus our k, which is 4. Then simplifying, we've got x minus 2 squared equal to negative 4 times 1. That's negative 4 divided by 4. That will be equal to negative 1. So instead of writing negative 1, this will be now negative only because we will be multiplying that 1 to y minus 4. So that would serve as a negative times y minus 4. So this is now our standard equation of our parabola. So I hope that you were able to follow through. Please study, practice and practice, repeat the process, and you will eventually remember all the steps in the process in writing our standard equation.